let's consider Jack first of all. He dances around the maypole clockwise, going one revolution every 5 seconds. So that's 360 degrees in 5 seconds, clockwise. Divide through by 5 gives 72 degrees in 1 second, and essentially that's his speed. Then Jill is going 360 degrees in 6 seconds, but opposite direction. But divide through by 6, here we've got 60 degrees in 1 second. And therefore their relative change in angle, or relative speed, I guess, relative change in angle per second is going to be the sum of these two. 60 plus 72, 132. And in 1 minute, the relative change of angle will then be 60 times 132. So let's work out the number of passes, because if we work out how many 360s go into this, then that will tell us how many passes they've made. So number of passes will equal 60 times 132 over 360. For example, if in 1 minute their relative change has been 360, then they would have passed each other once. They'll be exactly back where they were. If it was 720, the relative change, then actually, sorry, we can't say for sure they'll be exactly where they were, but we can say that they're 360, like they are on opposite sides for sure. Um, So yeah, that's what I'm just trying to justify why we're dividing by 360. Now, what I can do here is just cancel out the zeros, divide top and bottom by 10, and cancel out the 6 and the 36 partially, leaving me 132 divided by 6. And that gives me 22. So the number of passes is going to be 22. I think that is the best approach. I did it in a slightly different way, so I just thought I'd share it. I again worked out their speed essentially, 72 degrees per second and 60 degrees per second, and therefore 132-degree difference in relative change per second. And then I actually did 180 divided by 132. That was to find out how long it would take them to kind of catch up with one another. For Jack to move to say, does he go faster? Uh, so Jill, no, oh yeah, he goes a bit faster. So maybe they meet, well, they're in line, say here. So that's going to be after they've relatively moved 180 degrees. So 180 divided by 132. This is a little bit trickier. So I cancelled things down. I divided both through by 6, give 30 over 22, and hence 15 over 11. So that's seconds. That's to pass the first time. And then we can almost reset the clock and just find how many times they pass from then on. So they then pass every 30 elevenths of 30 eleventh seconds. It's going to be more than 1 second. So I just want to work out like how much this goes into 60. So I can do 60 minus 15 over 11, which gives 660 over 11 minus 15 over 11, and hence 645. 11ths. So that is for them to pass they've passed once. Now I want to know how many 30/11ths go into this to find out how many times they pass again. So I can divide by 30/11ths. I can either times by 11 over 30, or you can, when these two are the same, just cancel them out. It just becomes 645 divided by 30. So that's going to be 64.5 divided by 3, which gives 21.5. So overall, they've to meet each other the first time and do half a revolution. Uh, that took 15 over 11, and then they're going to do another 21.5 revolutions. So in total, there'll be 22 times that they pass each other. So I think that way is more complicated to be fair, but it also works.